Hello and welcome to this tutorial on this beautiful day. Today we are going to be looking at equations of tangents and normal to curves. We are going to be using the topics of differential calculus and also equations of a straight line to deal with this tutorial. Now recall from differential calculus that the gradient function is written as dy over dx. What this means is that, for example, if you have a straight line, so this is coming from equations of a straight line, recalled from equations of a straight line, that if you have the graph, if you have my x-axis and y-axis, and we have any straight line on this graph, to find the gradient of this graph, we simply take 2 points, say point A, and another point, say point B. So we can draw a triangle. So this is going to be changing y, which is dy, and it's going to be changing x, which is dx. So to simply find the slope of this line, we're going to look for m, which is the slope, changing y over changing x, and this is simply y2 minus y1 over x2 minus x1. So under equations of a straight line, this is how we define the slope of a straight line. Recall also that if you are given a curve instead of a straight line, let's look at a quadratic graph. Say I have a quadratic graph of this form and I'm to find the slope. So unlike in the case of straight line, that whenever we are looking for the slope, we can just look for the slope at any point. Majorly, whenever we are looking for slope of a curve, it's usually at a point of reference. So I might have to look for the slope of this curve at the point x equal to 2. So if I have this to be equal to x2, so what I have to do is to simply draw a straight line to where it meets the curve, and from there I'm going to draw a tangent to that point. So drawing this tangent, I can now pick any 2 points on this tangent, say point A and also point B. So drawing triangle once again. So this is going to be changing y now, and it's going to be changing x. So this is how we can simply find the slope of a curve, which is the gradient of a curve at a point of reference. So we are going to be using these two facts, these two graphs in this graph to calculate the equation of tangent and equation of normals to curves. So here, if I'm to write the expression of this gradient, it's going to be dy over dx at the point x equal to 2, because the gradient at each point is going to be different, unlike the straight line that have a general slope. So let's start this tutorial fully. Now also recall that under equations of a straight line, whenever we are trying to calculate the equation of a straight line with gradient equal to m, we simply use the formula m equal to y minus y1 over x minus x1. So this can also be written as y minus y1 equal to m x minus x1. So we are going to be using the equation, this particular formula, fully in this course. So lastly, before going to differential calculus, also recall that under equations of straight line, we know that if you have two lines which are perpendicular to each other, say I have a line A and another line A. So if these two lines are perpendicular to each other, meaning that there's an angle of 90 degrees between the two lines, and if the slope of line 1, if the first line has a slope of m, so the second line has a slope of m prime, the relationship between these two slopes is m prime is going to be -1 over m. Or we simply say that if you multiply the slope of the two graphs, we are going to get -1. So m multiplied by m prime equal to -1. So take note of this. Also, we are going to be using this expression fully in this course. So after you establish all these facts, we can now move straight into the tutorial. But another thing before we start looking into differential calculus is the concept of normal. Normal. So we simply define a normal as a straight line perpendicular to the tangent at the point of contact of the tangent to the curve. So say for example, if you have any curve, say I have this curve, and at this point I have a tangent at the point. So any line drawn that is perpendicular to this point is referred to as normal. So if I draw a line which is perpendicular to this, so this is simply the normal to the curve. So now let me just take us back to the equation of a straight line. So from equation of a straight line, we have that y minus y1 equal to m minus m1 equal to m bracket x minus x1. So if you are trying to look for the equation of the normal, we simply take that the two lines are perpendicular to each other, meaning that if you multiply the gradient, you must get -1. So you're going to be using this principle to find the equation of tangent and also equation of a normal to curves. Say this is our curve, this is our tangent, and here we have our normal. So if you can find the equation of a tangent using equation of a straight line, you can also find the equation of a normal using m multiplied by m prime equal to -1. So let's start looking at some examples. Okay, so if I have, so here we have the first example, and we have to find the equation of the tangent and normal to the curve. Why? So find equation of the tangent and normal to the curve y equal to 2x³ minus x² plus 3x plus 2 at point x equal to 1. So let's quickly go back to our explanation. So here we have a curve. It can be of any curve, and we have to find the gradient at point x equal to 1. In this case, recall that I explained that if you have a straight line, you can always find the gradient at any point on the straight line, and it's going to be the same thing. So if you take the gradient, if you take these 2 points, we are going to have the same gradient. If you take this point, we are going to have the same gradient. But in the case of curve, it's not like that. The gradient at this point is different from the gradient at this point, is different from the gradient at this point. So meaning that whenever we are looking for the gradient of a curve, it's usually at a reference point. So, and for this example, I use reference point of 2. Finding the gradient of the curve at point x equal to 2. So what we have to do is to draw a straight line from point x equal to 2 up to the point that it meets the curve. And from there, we are going to draw a tangent to that point. So now from our example, we have to look for the equation of the tangent and normal to this curve y equal to this at a point x equal to 1. So what we are simply saying is that this point is now equal to 1. And after drawing it to the curve, we draw a tangent. So this tangent is now a straight line. We can now use the equation of a straight line to find the equation of the tangent. But before we do that, we simply have to get what our gradient is. And we know that the expression of the gradient is simply dy over dx. So differentiating this equation, we have 6x² minus 2x plus 3. So this is the expression of the tangent of the gradient. So at point x equal to 1, we're going to have our dy over dx to be equal to 6 1 squared minus 2 1 plus 3. So this is 6 minus 2 plus 3, and this equals to 7. So I have my gradient m to be equal to 7. And also at point, so before, I think let's write back the equation of a straight line, how to find the equation of a straight line. So the formula is simply y minus y1 equal to m x minus x1. So from what we have here, we've gotten m, which is the gradient, m equal to 7. So we don't need to look for y, and we don't need to look for x. And we've also gotten x1, which is 1. We're given that at point x1. So now the next thing we're looking for is getting y1. So y1 is simply substituting the value of x1 into our expression. So we are going to have y1 to be equal to, so we now substitute 1 into this expression. Two 1 cube minus 1 square plus 3 1 plus 2, and this I have the answer to be equal to 6. So I now have my y1 to be equal to 6. So I have x1 also y1. So from there I can now calculate the equation of the straight line, which is simply the tangent to the curve at point x equal to 1. So I have the expression, the formula to be written as y minus y1 equal to m x minus x1. So I have y minus y1, in this case it is 6, equal to 7 x minus 1. So I'm going to have y minus 6 equal to 7x minus 7, and this is simply y equal to 7x minus 7 plus 6. So this is y equal to 7x minus 1. So, and here I have the equation of the tangent to the curve. So the next thing I have to calculate is the equation of the normal, and we know that the normal is always perpendicular to the tangent. So if I have the slope of the tangent m to be equal to 7, so therefore if m prime is the slope of the normal, if I multiply this by m, I'm going to have -1 from what we've seen earlier. So therefore, meaning that m prime is going to be -1 over m, which is simply -1 over 7. So if I have my m prime to be equal to -1 over 7, I can still use the same formula of equation of a straight line, since our normal is also a straight line, to find the equation of the normal. So again, equation of the normal, y minus y1 equal to m, in this case -1 over 7 x minus x1, and then I'm going to have y minus 6 equal to -1 over 7 x minus 1. So this is 7y minus 42 equal to -x plus 1. From here, I'm going to have 7y plus x equal to 43. And then I have the equation of the normal. So up here, I have the equation of the tangent. So that's simply how we can find the equation of the tangent and also equation of the normal. So basically you can see that we use the knowledge of differential calculus and also the knowledge of equations of a straight line. And since we know that our tangent is a straight line, we can use the equation of a straight line to find the equation of the tangent. And also the normal is perpendicular to the tangent. We can use the formula m multiplied by m prime equal to -1 to find the equation of the normal. So let's look at another example to better illustrate this point. Alright, this second example is on implicit differentiation. So if you are not used to implicit differentiation, this is not going to be complex and you're able to find your way around it in this tutorial. We have to find the equation of the tangent and normal to the curve x squared y plus y cubed x plus 3x minus 13 equal to 0 at point x at point 1, comma 2. So we notice that in this case, instead of differentiating with respect to x, we are going to be differentiating with respect to both x and y. Therefore, we are given 2 points 1, comma 2. So the point x equal to 1 and point y equal to 2. So first thing we have to do is to find the y over the x, and we need to differentiate the expression implicitly. So we have the expression x square y plus y cube x plus 3x minus 13 equal to 0. So the major principle in implicit differentiation is if you are differentiating x, we are going to keep y constant, and if you are differentiating y, we keep x constant. And whenever we are differentiating y, we simply add the y over dx at the back of our expression. So we are going to see it clearly now. So the first thing, if you are differentiating x, which is the first expression here, so we're going to keep y constant. To differentiate x, I'm going to have 2xy. So nothing will happen to y, but x will be differentiated. So the next thing, add and also differentiate y. So if I'm differentiating y is going to turn to 1 and x will be kept as x squared. But whenever we are differentiating y, we simply add the y over dx at the end of our expression. So that's how we are going to be doing for the whole thing. So moving to the second expression, if I differentiated y, I'm going to have 3y squared x y over dx plus y cube plus 3 equal to 0. So now putting all the y over dx together and also the ones that also have the y over dx together, I'm going to have x squared y over dx plus 3y squared x y over dx equal to negative 2xy minus y cube minus 3. So here I can factorize. And I'm going to finally have my d over dx as the expression minus 2xy minus y cube minus 3 all over x squared plus 3y squared x. So this is the expression of my gradient function d over dx equal to this. So now looking for d over dx at point 1, 2. So to find d over dx at point x equal to 1, y equal to 2. So I simply substitute x to be 1 and y to be 2 in the expression. And then I'm going to have negative 2, 1, 2, minus 2 to the power of 3, minus 3, divided by 1 squared, plus 3, 2 squared, 1. And then I have that to be equal to negative 15 over 13. So I have my m to be equal to negative 15 over 13. So m equal to negative, let me try to change the color there. M equal to negative 15 over 13. So I have my y1 to be equal to 2 and my x1 to be equal to 1. We have been given this from the question. So yeah, we already have our x1, y1 and m. So the next thing is to calculate the equation of the tangent straight. And recall from the equation of a straight line, we have the equation of the tangent to be equal to y minus y1 equal to m x minus x1. So y minus y1, which is 2, equal to m negative 15 over 13 equal to, x minus 1. And from here, I'm going to have the equation of the straight line to be equal to 13y plus 15x minus 41 equal to 0. So here I have the equation of the tangent. And lastly, to calculate the equation of the normal, I simply use the same expression, m multiplied by m prime equal to negative 1. So I have my m to be equal to negative 15 over 13. So to find the slope of the normal, it's going to be m prime equal to negative 1 over negative 15 over 13. And this simply is 13 over 15. So again, I can use the formula y minus y1 equal to m, in this case is now 13 over 15 x minus x1. And substituting x to be equal to 1 and also y to be equal to 2, I'm going to have this y minus 2 equal to 13 over 15 x minus 1. And lastly, I have the equation of the normal to be equal to 15y minus 13x minus 17 equal to 0. And this gives me the equation of the normal. So to cap it all, to summarize, so there are basic formula that you're going to need to calculate the equation of the tangent and equation of the normal. So the first thing is simply looking for the gradient function, which is dy over dx, the equation of a straight line, which is y minus y1 equal to m x minus x1, and lastly, equation of the normal, which is m multiplied by m prime equal to negative 1, or you simply write this as m prime equal to negative 1 over m. So having a good handle of these three expressions, we can calculate the equation of the tangent and equation of the normal to a particular curve. So that's it for this tutorial. I hope you enjoyed the classes. Don't forget to give it a thumbs up, and if you are yet to subscribe, kindly subscribe to this channel, and I'm going to see you in the next tutorial. Thank you.